In this video, we're discussing the relative position of two lines. So when we have the equation for two different lines, what information can we know about how those two lines are related to one another? So let's assume we have line 1 is equal to a1x plus b1. So basically it's just our y equals ax plus b, but we've identified the slope as a1 and the y-intercept as b1. So that for line 2, we're talking about a different line, it has a2. This just means that its slope is different from a1. So a2 times x plus b2, which indicates it's a different y-intercept. So there are actually 4 cases where we can determine how the lines relate to one another depending on what their slopes are and what their y-intercepts are. So the first case is when we have distinct parallel lines. So if our lines are distinct parallel lines, well, parallel means that they have the same slope. We should already all know that. So that would mean that their a1, or the slope for line 1, is equal to slope of line 2. But they're distinct lines. That distinct means different. It means they're not the same line. Well, if they are different lines, then it means that they have different y-intercepts. So the y-intercepts are not equal to one another. So we can see that in this example here. We can see that line 1 and line 2 are parallel, but their y-intercepts are different. So an example of that could be y equals 2x plus 3 and y equals 2x minus 1. So here we see we have the same slope, our a's are the same, but our b's are different. So that's what makes the lines different. They have the same slope, so they're parallel, but they're distinct or different because their y-intercepts are different. The next case is coincident parallel lines. Basically, that means that the two lines overlap each other. One line goes on top of the other. So that means we have the same slope and we have the same y-intercept. So if I were to graph both lines, both of them would end up being graphed one on top of the other. So an example of that could be y equals 3x plus 1. And you could also have 2y equals 6x plus 2. So for this second line, it's not in function form, but we know that we can isolate y to put it in function form. And you see once we've isolated y, we divide everything by 2. We end up with both the exact same rule. So it's coincident, meaning they overlap one another, parallel lines. The third case are perpendicular lines. So as we've learned about perpendicular lines, their slopes are negative reciprocals of one another. And we've already seen this, but we'll review again. To check if slopes are negative reciprocals of one another, if you multiply the slopes together, they should give us negative 1. So if we have perpendicular lines, their slopes, when we multiply them together, are negative 1. And their y-intercepts are different. Actually, they don't have to have different y-intercepts. Often their y-intercepts are different. But it could happen that this is just actually over here. This y-intercept is over here, and then we have our perpendicular lines crossing at the y-intercept. That could happen as well. So, for example, we could have this rule, y equals 1/2 x plus 1, and we could have y equals negative 2x plus 3. So to check if they're parallel, we check to see if when we multiply their slopes, 1/2 times negative 2, is it going to give us negative 1? So negative 2, that's like 2 over 1. So we multiply them together. 1 times negative 2 is negative 2. 2 times 1 is 2. And we reduce this, it gives us negative 1. So that means they are perpendicular. Our last case are basically when you have lines that are intersecting and they're not perpendicular. So basically there's no special relationship between the slopes. The slopes aren't equal. They are not equal because they're not parallel. They are not negative reciprocals because they're not perpendicular. And often their y-intercepts are not equal. But this could happen. They could be intersecting like this at the y-intercept. So they could have the same y-intercept. but often they don't. So an example of this would be, well, y equals, let's say, 3x plus 1, and then y equals 5x minus 2. The slopes are different. They are not negative reciprocals of one another. So they're non-perpendicular, and, well, if they're not parallel, they'll for sure intersect at some point. So they're non-perpendicular, but intersecting lines. Now we'll try an example. So you're asked to determine the relative position of the following pairs of lines. So here we have two equations representing two lines. We need to determine which case is this representing. Are they distinct parallel lines, coincident parallel lines, perpendicular lines, or non-perpendicular intersecting lines? So we need to look at their slopes and their y-intercepts. So let's call this line 1 and line 2. So for line 1, the slope is 2, that's my A, and the y-intercept is negative 3. For line 2, the slope is also A, and the y-intercept is negative 5. So we know that our slope of 1 and slope 2 are equal to one another. A1 is equal to A2. So if the slopes are the same, that means that they're parallel. Now, are they parallel coincident or are they parallel distinct? Well, since the B1 does not equal our B2, I'll label these B1, B2, the y-intercepts are different, well that means that these lines are distinct. They're different lines. So distinct parallel lines. Now in this example, again, I'll label this line 1 and line 2. Well, for line 1, my slope is 3, and my y-intercept is 4. For line 2, my slope is negative 1/3, and my y-intercept is negative 2. So our slopes are different, so it's definitely not parallel line. So by looking at them, we might think, well, they look like they're negative reciprocals. We'll just confirm. We'll multiply them together. 3 times negative 1/3. This is how we properly show our work, how we can prove what we're thinking. So if we multiply them together, it should give us negative 1 if these two lines are perpendicular and the slopes are negative reciprocals. So we multiply this together. 3 times negative 1 is negative 3. 1 times 3 is 3. That gives us negative 1. So that tells us that these two slopes are negative reciprocals of one another, so that means these lines are perpendicular. So they're just perpendicular lines. Now I'd like you to copy down the secret question. Create an example of two lines that are A, coincident parallel lines, and then another example where the two lines are B, distinct parallel lines. So for each line, you are writing two equations. For each example, you're writing two equations. An equation for each line so that these two lines are parallel coincident, and then you're going to do another set of two lines so that the two lines are distinct parallel lines. Please bring that to class.